All right. So today we are going to combine ellipses and hyperbolas. They're very similar in how we set them up and find information. And we're going to work backwards. So I'm going to give you information about a graph, and I'm going to ask you to write the equation. Okay? So just a reminder of some things that we know about an ellipse. Okay? We find the center. We have major vertices. We have what I call minor vertices, and we have foci. All right? I don't know if we've really talked about it, but planets do orbit in elliptical patterns. So ellipses are very useful to the real world and the world. A hyperbola has a center, vertices. We use the b value to get our rectangle to draw our hyperbola, and then of course we have foci as well. All right, so let's just recall very quickly the standard form for ellipses and hyperbolas. All right, so if we have an ellipse and it opens horizontal, how do we pick that out? How do we pick out that it's horizontal versus vertical? The greater what? The bigger denominator is under the x. Okay, so remember in an ellipse, A is always big. A is always bigger than B, all right? And that is how we tell whether we have a horizontal or vertical ellipse. Okay. Will, how do we find C for an ellipse?
It's a squared minus b squared.
Good. How do we determine horizontal versus vertical hyperbola?
X squared is positive.
Okay, for horizontal, the x minus h squared is the positive one. And for vertical, it switches. Remember, for hyperbolas, it does not matter which denominator is largest. It matters which denominator is attached to the positive squared variable. And Marissa, how do we find c squared for a hyperbola? A squared. Good. For each of these comments, you need to know three things in order to be able to write your equation. You need the center, HK, you need A, and you need B. Now, you may not directly be given the center A and B, but with enough information, you should be able to figure it out. All right? So what I'm going to do is I'm going to go through one example with you, and then I think you have enough tools, and I think that you will remember the process better if you can work together to solve through the rest, as opposed to me telling you what you should do. Okay, we're going to work on our problem solving skills today. All right, so we're going to start with an elliptical example. Okay, go ahead and write down that A, we have an ellipse. B, we have vertices at plus or minus 6, 0. And our foci are at plus or minus 2, 0. I will always ask that you draw a picture. Okay. I would also suggest that you label the coordinates so you know which ones are your vertices, which ones are your foci, etc. Especially now that we're intermixing ellipses and hyperbolas. All right. So tell me some things that we know from this picture. Gabe, what's one thing we know? What is it? How do you know that? Okay. Oh, and what is 0, 0? Ah, that's probably good to know too, right? Okay, so 2 for 1. We know that our center is 0, 0. It has to be in the center. We know that our A value is 6. That's how far away our vertices are from that center. Okay. Hannah N., what else do we know?
I can do 2 squared equals.
Oh, you're a step ahead of me. You're a step ahead of me. What's the 2? Okay. So what variable does that give us? Okay. But I like where your head is. What direction does this open? Horizontal. Our vertices are horizontal from the center. So what I'm going to do before I go back to what Hannah was trying to tell us, I'm going to go ahead and write down our horizontal ellipse formula. We can determine, or we know, that our center is at 0, 0. And we know that A is 6. Now we have the information about C. C is 2, but C is not very helpful right now for writing our equation. Or is it, Hannah? I'll let you go ahead and continue with what you were trying to say earlier.
We can plug in for, like, if we were finding C, but instead of finding B, we're going to have 4 equals 36 times B squared.
Okay, so we know that C squared is A squared minus B squared. So we have C and we have A. We can plug those in to solve for B squared. Okay, so if I add over B squared and I subtract 4, B squared would be 32. Now, here's a piece of advice. For your equation, do you need B or do you need B squared? B squared. There's no point in solving out for B. Just stop at B squared, and then we can come back and replace it. Okay? So we can write that the equation of our ellipse is x squared over 36 plus y squared over 32 equals 1. Once you solve for the a squared or the b squared, you can stop and plug it into your equation and make your life a little easier. All right, so now here's your task. I'm going to give you problems to work through to